In this problem, we want to try to work through this transcendental function. So we go through our steps. 1, can we put in 0? No, that's not going to be good. 2, can we factor and cancel? It's not in the factor. 3, can I rationalize? Nope, no, that's not going to be a good idea. So I have to use some of these top tricks in order to be able to figure out what's going on.
I'm afraid we need to use math.
The first thing I might be thinking about is like I've got a squared and none of the things that I have squareds in them. So I want to break that limit up into two separate limits. So this is the limit as x is approaching 0 of tan x over x times another limit of just tan x, because tan x times tan x, that's tan squared x. Um, All right, now this thing is really starting to look like that, but not quite. It's got a tangent instead of a sine. So could I make this piece right here into a sine x over x? Because if I could do that, then I'd be able to use that trick up top. Well, what do I know about tangent and sine? Well, tangent is sine over cosine. So if I multiply this by a 1 over cosine x, this sine over cosine is the same as this tangent, and I've got an equivalent expression. Plus, I'll be able to have two more limits that I hopefully will be able to evaluate. Filling in the rest, I want to try to break up these limits one more time using that product property of limits. So I've got the limit of sine x over x times a limit, of 1 over cosine x times another limit of tan x. Now, I sure hope that I can evaluate these things. I'm kind of just moving on a hope and a prayer right now, but I'm trying to get them to match those things up top. And then after that, decide, okay, well, what can I actually do with this? So this one, the limit right here is taken from the top, so that's just 1. Can I direct substitute the other ones? So this next limit would just be 1 over the cosine of 0. So what is the cosine of 0? Well, the cosine of 0 is 1. Okay, well, that's just 1 over 1, so that's just a 1. Great. Multiplied by the tangent of 0, again, using direct substitution. What is the tangent of 0? Well, the tangent of 0 is the sine of 0 over the cosine of 0. Cosine of 0, we just talked about, is 1. Sine of 0 is 0, so that's just 0. Oh, and after all of this, this limit ends up just being 0. Well, fine. I still got a limit, though. Hooray! In this example, I again want to try to use my transcendental tricks in order to be able to figure out what is the value of this function. Direct substitution is just not going to cut it. So I want to get rid of that 2 because that 2 feels like a little bit of a misfit. So any sort of constant I can put in front of my limit. And then I'm left with a sine of 3t over t. And man, like it's still not quite matching up. I don't know what to deal with that 3. The one thing I'm noticing is in my sine function, these are just the same value. It's just an x and an x. So could I make these two be the same value? I can't get rid of that 3, but what if I added a 3? So divided this thing by 3, but I can't just like randomly divide that thing by 3. I need to put another 3. Now those two circles are matching the top two circles. Just like before, the 3, I can bring that in front, just like I brought the 1/2 in front. So now I've got a, 3 halves. And now this is the limit of sine of 3t over 3t. And this is the limit as x as, wait, nope, t is approaching 0. Now it's still not quite matching because I still got those 3's. So the general idea of what I want to do is I want to say let y equal 3t, because then we get this sine of y over y.
Math.
That's making it more match that thing I've got up top. So now I've got a limit. I've got my 3 halves. I've still got the t that's right here, that t is approaching 0. But as t approaches 0, 3 times that value of t is also going to head towards 0. So as t approaches 0, y also approaches 0, which is great because that lets us apply our thing up top here. That makes this whole green limit into just a 1. Times our 3 halves, our limit is going to be 3 halves. All done. That was a weird one. That's the end of our video of determining limits analytically. Reminder to use all your properties of limits and these different ideas to try to twist and turn the expression that you have into something that you are able to evaluate the limit for, either using those special limits or rationalization, factorings, and any other algebraic tricks you want to use. Thanks for watching. Bye-bye. Use some of these top tricks in order to be able to figure out what's going on. How the frick do I even do that?